Hi there. So in this video we're going to be playing around with square roots, more or less, to discover how surds work and why they do. So let's say I gave you two values. One of them is the square root of a times b, which we can in this case write it as the square root of ab, because we're going to get rid of that multiplication sign. And let's say our second number would have been, let me change color for this one. Let's make it this light magenta. The square root of a times the square root of b. And you can see that I've made them quite far apart, so it's clear that they're not the square root of ab, but the square root of a separately times the square root of b. And let's say I asked you to square each of these values. So in one end you'd have the root of ab squared, that means ab raised to the power 2, and on this end you'd have the root of a times the root of b entirely squared, or raised to the power 2. Let's work both of them out and see what we get. And let's work with this end first, the root of ab. Well, the square root of ab can be written as ab whole raised to the power half. That's what the square root of ab is. The square root of ab is this value. So when I say I'm looking for the square root of ab raised to the power 2, all I'm saying is I want this value here, ab whole squared, ab as a whole raised to the power half, squared. I'll use square brackets in this case, just so you can see that it's the square root of ab raised to the power 2. Well, now we can see that this is sort of equal, right? I'm saying the same thing, just working with indices, more or less. So what do we know about indices? If I raise an index to another index, so in this case I'm raising ab to the power half raised to the power 2, well, all I got to do is multiply the indices, multiply the powers. So this would then be ab as a whole, right, raised to the power a half times 2, which in this case would be simply ab raised to the power 1, which is the same. Anything raised to the power 1 is itself, so ab raised to the power 1 would be ab. Alright, and we know we found that out, so we can say the square root of ab, the square root of ab raised to the power 2, let me scroll a bit to the left for that, raised to the power 2 is equals to ab. Now let's work on this end. Let's work on this other magenta end of our calculation, of our workout. Well, the square root of a separately is a raised to the half, right? And this is from our indices, right? I hope you remember this rule from your indices. And in this case, the square root, well, by the way, before I go any further, if you don't remember that the square root is raised to the half, please check out the videos on the indices. Thank you. Anyway, so I was saying the square root of b would be b raised to the power half, right? So this value here, this would then be, instead of writing square root of a, I could write a raised to the half, right, separately, times b raised to the half, squared. And if you remember from your indices, what happens when we have these two values expressed as powers as raised to another power? Well, that would just mean this 2 is multiplied by the power here and is multiplied by the power here, right? So this would then be a raised to the half times 2 times 2, right, times b, and let me put this up here in brackets so you can see what I'm doing, times b raised to the power half times 2 as well. So what would this be? Well, this would be a raised to the power 1, a raised to the power 1 times b raised to the power 1, because a half times 2 is 1, right? And in this case, anything raised to the power 1 is itself, so this would be a times b, which is also ab. So you notice here something. You know something here. When I square this value, this root of ab as a whole, I get ab. And when I square this value, root of a times root of b, right, I get ab as well. Well, what does that mean? What does that mean? Well, let's think about square roots. What is a square root? A square root is a value that I multiply by itself to give me ab. Or in this case, a square root is a value I raise to the power 2 to give me to give me a value, right? So in this case, if I asked you what is the square root of ab, the square root of ab would be the number or the value I raise to the power 2 to give me ab. So in this case, we're working with green, the root of ab is the square root, square root of ab. Yep. And let's look at this other end. I also squared this value. To give me ab. So does this not also mean that the square root of a times the square root of b is the square root together, right? Is the square root of ab. That's what it means. And let's think about values. If I asked you, let's think about a value like 64, and I asked you, what's the square root of 64? The square root of 64 would be 8. In this case, let's take only positive values. The square root of 64 would be 8. And 8 is the only square root of 64. There is no other square root you can think of that gives you 64 when you raise it to the power 2, right? Other than 8. 8 is the only number. If you look at 25 and you square root it, that would be 5. And 5 is the only number you can square to give you 25. So if I have if this value here is my square root of ab, and this right here is my square root of ab, and I know ab can only have one possible square root just by this little inductive reasoning, well then that must mean that because these two are square roots, they must be equal to each other. But the only difference is that they are expressed differently. So root of ab is the same as root of a times root of b. And this right here, ladies and gentlemen, is one of the fundamental ideas behind how square surds work. So I want you to remember this concept, this little formula over here. And in the next few videos, we'll be working with it and seeing how we can apply it to different examples and how it works out. But for now, I hope you've actually appreciated the idea that one number can only have one possible square root, right? No other. Therefore, these two must be the same value. And I hope that made sense and it was clear how we got it. So I'll see you in the next video. Thank you for watching.